On PSC3-3, we're going to talk about what happens when we do two transformations in a row. So if you do one transformation, and then you take that new image and you immediately do another transformation to it, that is called a composition of transformations. And we're going to do some of these together and talk about what happens. So first we're going to do x plus 3y minus 2. And I'll draw that one in pink. So I'm going to go over 3, down 2. And I know these points aren't labeled, but I'm going to label them for myself. I'm going to call that A prime. And then over 3, down 2, I'll call this one B prime. And over 1, 2, 3, down 2. And this isn't the best scan, but we're working with what we can right now. So I've got this pink triangle. That's my new pre-image. I'm going to take that and I'm going to do this next transformation to the pink triangle. I'm going to do that one in blue. So now I'm going back 1, down 1. So I get A double prime is here, B double prime, and C double prime. And the result is just a transformation. And what we want to think about is how could I have gone from the black triangle to the blue triangle without that step of the pink one in the middle? And when I look at those, I could have gone 1, 2, over and down 1, 2, 3. So I could have done x plus 2, y minus 3. And when I think about math, well, that's just adding these. Right? 3 minus 1 gives me positive 2. Negative 2 minus another 1 gives me a negative 3. So when I have two translations in a row, where I'm going to pick up and move again, I can add those all in a row and do it all in one step. Now we're going to practice reflection a little bit. So I'm going to reflect over this blue line. And this is going to be a terrible reflection because I don't have a mirror or patty paper to help me at all, and I'm trying to do it all on my iPad, so bear with me. And you get something that looks vaguely like that. Go with it. Every point is going to be the same distance if I were better at art. So if this is 3 centimeters, let's say, this will also be 3 centimeters to that line. It doesn't look like it because I'm terrible at art. We're going to think about what happens now if I do it twice in a row. So if I copy that triangle and I reflect it over, I get something like this. And then if I take this blue triangle and I reflect it over the next line, I get, this is getting worse as I go. Okay, that's slightly better. It's still pretty bad. What ends up happening, if I were better at art, it would be more obvious to see that when I reflect it over this line, and then I reflect it again over that line, I end up with the mirror image of the mirror image, which is identical to this one. So really, I'm just sliding this over. So if I reflect over two parallel lines, that's the same as a single translation. It's as if I just picked it up and moved it over. The distance is also going to be twice the distance between the two lines. And here's why. Let's say this point is 4 from here, and let's say this is 8. That means this point is 4 away, which leaves 4 right here. And when I reflect that over, it'll be 4 as well. I'm going to pick different numbers because I don't like that my example ended up with so many 4s. This is why I should have picked numbers ahead of time. Let's say it's 4 away there, and we'll make this entire distance 12. Since I took up 4 here, this much must be 8, so I'll have 8 there. Well, 4 plus 4 plus 8 plus 8 means that point A and point A double prime has to be 24 apart, which is exactly twice of 12. We're going to do an example of that. Point A is 6 from line M and 16 from line N. So there's 10 in between. If I reflect it over, I get A prime. And if I reflect it over again, I get A double prime. I know based on my rule that it must be twice the distance between the two lines. So the distance between A and A double prime is 20 centimeters. If I want to prove it to myself, or if I'm not sure, I can think through that. Okay, this much is 6, which means there's 4 here. When I reflect this point a second time, 4 will be over here. And I can add up 6 and 6 and 4 and 4 and get 20. Now we're going to reflect over lines that are not parallel. And this one I'm even worse at drawing. And I really wish I had mirrors and patty paper and all those things, but I don't, and that's okay. So I'm going to reflect it once, and then I'm going to reflect it again. It's pretty terrible drawing, but hopefully you're able to visualize that this becomes a rotation. So if I do 2 reflections over lines that are not parallel, it is a rotation. And we could do this by hand and measure it all if we had time and materials and could hang out together. So you'll just have to trust me for now because we can't do that. The angle of rotation will be twice the acute angle. And if you're able to and you have the right tools at home, you can absolutely have some fun measuring that and proving it to yourself. Or you can just choose to trust me. So if I were to reflect B over this line and then over this line, this angle will be twice the angle of the lines in between them. And I always have to pick the acute angle. So it'll be an 80-degree rotation. Lastly, if I do a translation and then a reflection, I get what's called a glide reflection. And a great real-world example of that is footprints, right? So if I drew a line right along here, you can see, okay, you're moving your foot forward, but then you're stepping with the mirror image over here. And then it moves forward, and you mirror image it there. And it goes forward, and a mirror image there.